today's lesson, we're looking at sums and differences of angles. I'm just going to quickly show you the very first formula. And so angles can be expressed as sums and differences. The reason is you know the exact values for angles with 30 degrees, 45 degrees, and 60 degrees. However, we can come up with other combinations. So you know exact values for sine 30, cos 30, tan 30, etc., 45 and 60. Now, because when we use these sums and differences of angles, so we've got sums and differences of angles, instead of, so what we can do now is we can look up things like sine of 75, because that's 30 plus 45. Sine of 105, because that's 60 plus 45. Sine of 15, because that's 15 is 45 minus 30. So what we can do, or it's 60 minus 45. So what we can do, we can find sine, cos and tan of these other angles by using these particular formulas that we're going to use with exact values to do any combination of 30, 60 and 45 degrees. Okay, that's how we're going to use them, but we'll also use it for non-exact values as well. So for example, the cos of x minus y is this formula, but I'm just going to show you, just going to have a quick look at the proof. Now, if this here is the point, everyone, if A is the point, do you remember that this is the point xy, right? But if this angle here, where my cursor is y, you know, isn't it adjacent? So if this angle here is y, this point will be xy, because you know how x is cos theta, y is sine theta. This point will be cos y, sine y. If this angle, watch my cursor all the way around there, is angle x, this point here will be cos x sine y, because remember, x is cos theta, y is sine theta are the general coordinates. So if the angle, just watch the cursor, from here to here is y, and the angle from the x-axis to this other line here is x, then this angle in here is x minus y. For example, this might be 30 degrees, this might be 150, the angle in between would be 150 minus 30, which is 120. But what we're doing is coming up with an expression for the cos of x minus y in here. Now, so this point is cos y sine y, this point is cos x sine x. So if I join the line AB and call this the distance D, do you remember the distance formula? Y2 minus x2 minus x1 squared plus y2 minus y1 squared. Because if I call this the point x1, y1, and this the point x2, y2, what I'm really doing is doing x2, so I'm doing cos x minus cos y squared plus sine x minus sine y squared, using the distance formula here, using cos x sine x and cos y sine y as coordinates. If I expand that out using perfect squares, all right, so they're just being expanded. A minus b squared is a squared minus 2ab plus b squared, and this one's being expanded. And if I collect like terms, I end up with this expression here. Now, I know that looks complicated, right? So we've used the distance formula in this triangle, but we can also use the cosine rule in this triangle to come up with an expression for AB. And when that's done, I come up with this expression for AB squared as well. And if I put those two expressions equal to each other, you don't have to do this, right? We end up with this. So all I'm interested in is the rule. So that's what we're going to do, all right? So from there, once we've got, that's proving this first rule, this one here. Once we've proved the first rule, we can easily derive the others. But I'm going to show you. So this is called sums and differences of angles. The reason is, this one is a difference of angles. Can you see that? Cos of angle x minus y is this expression. We have to learn these. The next formula, there's 6 formulas, is the cos of x plus y. This is the sum of two angles. Does this make sense? All right. Then, so we do it for cos, sum and difference. Then we've got formulas for sine of x plus y. That's sum. This is difference of angles, sine of x minus y. And then we do substitutions to get tan of x plus y, because tan is sine on cos, right? So they prove that there. and tan of x minus y. Now, what I might do actually, okay, now we will prove the results in another lesson, okay? So what we're going to do here today is we're just going to learn the results. Now, the first one, so sums and differences of angles. So there will be a sum and difference for sine, cos, and tan. The first one, the sine of x plus y equals. Now, with this rule, it looks like this, and this is how I remember it. So remember that I've shown you sine first, even though I did show you cos first in the other video, like at the beginning of the video. So this one is sine x, sine y. No, it's not. Sorry. Sine of x plus y, the formula is sine x times cos y plus cos of x times sine y. Now, I don't need to put the little dot for times. If they're written next to each other, it means they're multiplied. So this is how, so that's the one, that's for the sum of two angles with this sine of sum of angles with sine. The difference of two angles formula is sine of x minus y equals sine x cos y minus cos x sine y. So with the sine one, you've got one of each. Sine x cos y plus cos x sine y. But you've got to remember which one's plus and which one's minus. So the way I remember is, for the sine one, keep the sign the same. See how this is the sine of x plus y? What I mean by keep the sign the same, this is a plus. Keep the sign the same. This is x minus y. This has a minus. So for the sine rule, with sums and differences, keep the sign the same. So for sine, keep the sign. So I'll write sine, the same. But the sine one is sine x cos y plus cos x sine y. Okay? Now, you will get just the basic formula on your formula sheet. So if the sine one is keep the sign the same, when we do the cos formulas, well, we make the sign different, but it's a different version of the formula as well. So the cos formula is as follows. Cos x cos y. Now, sine is the only one where you keep the sign the same, so this one is minus sine x sine y. So the cos formula is cos cos sine sine, but you don't keep the sign the same. You only do that for sine. So it's different sign for cos, all right? So that is the sum of two angles with cos. Here is the difference of angles with cos. It'll be the same formula, cos x cos y, but it's a plus, sine x sine y. Okay? And so they're the sine formulas. Keep the sign the same. Plus, plus, minus, minus. Cos, you don't keep the sign the same, it's different. Now there are two tan formulas. The tan of x plus y equals. Now I'm going to derive, I'll see if we've got, oh no, we'll do it in the other lesson, we'll derive it. Is, now the numerator, this one will be fractional. So it's tan x plus tan y. So you remember, if it's the plus one, the plus is on the numerator, over 1 minus tan x times tan y. So that's the formula for the sum of the two tan angles. And the formula for tan of x minus y will be the opposite of this one. So the tan of x minus y is the tan of x minus the tan of y. So the minus one has the minus on top, over 1 plus tan of x times the tan of y. So they are your formulas for sums and differences for sine, cos, tan. Now, in a minute, we'll just go back to the sine one to make sure that you don't mess it up, because you've got to have one of each thing. You got that? So notice for sine, you've got sine x cos y, but now I've got cos x sine y. Please don't do sine x cos y sine x. It's xy, xy. And look, I've got a sine x and a cos x and a cos y and a sine y. There's got to be one of each different thing. You can't double up on cos x. All right? And same with this. So you go xy, xy. Same with these. So we go xy, xy, sine, cos, cos, sine. But this one is cos, cos, sine, sine. Cos, cos, sine, sine. Now you will remember these later once we learn the double angle results, which will be in another lesson or two. Once you learn the double angle results, these are easier to learn, all right? The formula sheet, they've only got the angle, you know, it is sums and differences of angles, but they only show you the sum ones. Sine, keep the sign the same, okay? So we've got theta. So we've got theta and theta. So notice it's sine cos plus cos sine. Keep the sign the same. The cos one is cos cos minus sine sine. And the tan one, the plus has the plus on the numerator and the minus on the denominator. So you do get the basic formulas for sums, but it doesn't show you the formula for differences. We're just practicing the formula. You'll never be asked anything this basic, all right? So just some examples from the textbook. Expand sine of x plus 20. We're just practicing the rule. So isn't this one the sine cos? Keep sine the same. So it's sine x cos 20 plus cos x sine 20. Okay? With the tan one, does the plus go on the numerator or the denominator? Numerator. Tan 48 plus tan of x over what? 1 minus tan 48 degrees tan of x degrees. Don't worry about the degrees. And the cos one is the cos cos sine sine result, but do you keep the sign the same? No. So it's cos 2 theta cos alpha plus sine 2 theta sine alpha. So they're just simple expansions. These will become, you know, very comfortable for you in the next day or so. In question 2, we're simplifying. We're sort of working backwards. Instead of expanding, it's like we're almost factorizing. So this is the cos cos sine sine. So this is the cos of the angles. Is it a sum or a difference? Do you keep the cos cos is from the cos expansion? Cos cos sine sine. No, we change the sign. It's this one. Cos of 28 degrees plus 27 degrees. Because the cos of x plus y is cos x cos y minus sine x sine y. I'll show you that result here. Just looking at that and comparing this. So see that? Cos cos minus sine sine. Cos cos minus sine sine is this result. Look, cos cos minus sine sine. That is the cos of x plus y. So you've got to notice or recognize the cos cos sine sine one is the cos expansion. All right? The sine expansion is the sine cos cos sine one. Okay? What do you think I should do with the 28 and the 27? Yep. So what do you get? 55. Of course, we don't have an exact value for cos of 55 degrees. We won't worry about that today. All right? What about the next one? It's the sine cos plus cos sine. That's the sine one, and we're keeping the sign the same. So it's sine of 2x plus 3y. The sine cos sine, look, sine cos sine is the plus one. It's keep the sign the same, it's plus. All right. So the other way you can remember it is, the cos one starts with cos, but you've got to, sometimes I might flip them around. But cos sine sine, that's the cos one, all right? And the sine one is sine cos sine. The tan one is tan, but you know on the numerator, is that the same sign as what's in the bracket? What's this one? Tan of what? Yeah, and are they like terms? Yeah, tan 2 theta. So the tan one with the denominator, the minus one has the minus plus. So it's, and notice that it's 1 plus, the same things multiplied by each other on the denominator. So it's the tan of 3 theta minus theta, which is the tan of 2 theta. Now, the next ones? The next ones are, what do you think you've got to do with these? You have to expand and simplify. So these are good practice. So the cos one, what's the cos one? Isn't it cos, cos, sine, sine? But is it plus or minus for the first one? Cos, cos, minus sine, m, sine, n, plus, here's the cos one again. What do I do with the sines? Cos m, cos n, plus, so change the sign for this one, plus sine m, sine n. Good luck. Wish I would have put A and B. So, wait a sec. Do we have two complete opposites? Though that and that cancel. So we've got 2 cos m, cos n. M and n are just bad choices there. Okay, and you have to do the same thing with the last one, but be careful because you've got a minus in between. So, are we good? Oh, I'll just pause for a second. So the sine one, keep the sign the same. So it's got to be the plus, but is it going to be, it's sine x cos y plus what? Cos x sine y. Minus two things. So I'm going to put it in brackets. What's the next one? Sine. So I've written my minus. Now what do I do? Sine x, what? Cos y, but plus or minus? Minus cos x sine y. But it's in brackets. So I've got sine x cos y plus cos x sine y minus sine x cos y. What do I do now? Plus cos x sine y. So these two cancel. The first and the third one cancel. And I get 2 cos x sine y. Now, you have cos 15. Remember, you only know exact values for 30, 45 and 60. You could come up with 15 two ways. 45 minus, no you can't, 60 minus 45. Any other way? That's it. 60 minus 30. 45 minus 30 as well. So two ways. Cos of 45 minus 30. Good with that? Or you could have done 60 minus 45. Sorry. Two ways. Yeah, there were two. Now, this is cos. Cos, cos, sine, sine. Do we keep the sign the same? No. So it's cos of 45 degrees, cos of 30 degrees, plus sine of 45 degrees, sine of 30 degrees. Yeah, so now we know the exact values for these. So isn't that 1 over root 2 times cos 30 is root 3 over 2 plus sine 45 is 1 over root 2, sine 30 is a half. Now, I do have a common denominator of 2 root 2. Because look, I'll just put these in brackets so you can see them nice and easily. And what is my numerator going to be? I do have a common denominator of 2 root 2. Isn't this root 3 plus 1 over 2 root 2? Now, we never leave our answers with irrational denominators. So what do we multiply the numerator and the denominator of this fraction by? Yeah, not 2 root 2, just root 2. So this will be times root 2 times root 2. Now the root 2 needs to be multiplied by each of those. So what do we get? Root 6 plus root 2 over 2 times 2 is 4. Can you see it's 2 times root 2 times root 2. Root 2 times root 2 is 2. 2 times 2 is 4. All right, you'll see that a lot, that expression. Root 6 plus root 2 on 4. Now the next one's a bit different. Tan of 285. Remember, if an angle is greater than 90, we can express it as a negative or a positive. For tan of 285, let me draw where it is. 90, 180, 270, it's here. Am I interested in this angle or this one? The other one. 360 minus 285 is what? I think it's 75. So this is 285. You know you cannot add up two numbers to give you 285. Well, you can, but they're not going to be 60, 45, or 30. So how else can I write the tan of 285? Isn't it negative tan 75? So whatever we do, let's just keep this negative out the front. We're just really going to work out tan 75, and when we're finished, we're going to throw a negative in front of it. All right? So that's negative tan. What will I do? How do I get 75? And it's not 60 plus 15. It's 45 plus 30 or 30 plus 45, which equals negative. I'm just going to put this negative out the front. Leave it. Don't try and incorporate it throughout. It'll get very messy. So what have I got? Tan of what? 45 plus tan of 30 over 1 minus. Remember, it's plus, same size, sign on the numerator, then it goes minus for the denominator, the opposite sign. Minus tan 45, 1 minus tan 45, tan 30, which is negative, bracket. Right, what is tan 45? 1 plus 1 over root 3 over 1 minus 1 times 1 on root 3. Now, do not go and make a common denominator, but I do have a denominator of root 3 that I want to get rid of. When you've got fractions within fractions, and it's just an expression like that, you multiply the numerator and the denominator by root 3. Numerator and denominator by root 3. So you're multiplying the numerator by root 3 and the denominator by root 3. So, root 3 times 1 is root 3. What's 1 on root 3 times root 3? 1. Over, root 3 times 1 is root 3. And root 3 times 1 on root 3 is 1. So I'm doing root 3 times that, root 3 times that, root 3 times that, root 3 times that. This is 1 times 1 on root 3. So it's just going to be root 3 on root 3, which is 1. So we have, sorry, why didn't you tell me you couldn't see it? Are you okay with that or no? So it's going to be negative root 3 minus 1. So now you've got to bring in the negative. Negative, actually, no, I wouldn't bring in the negative there because I'm going to end up with 3 negatives, you know. That's bad. So I'm going to put the negative on the denominator. I'll show you why. One sec. We could, yeah. So instead of going negative root 3 minus 1 over root 3 minus 1, when you've got 3 negatives in a fraction, don't go that way. You can have 1 negative instead if I put the negative on the denominator. So it's root 3 plus 1 over negative root 3 plus 1 is 1 minus root 3. Can you see that? That's better. Otherwise, I'm going to have negative root 3 minus 1 over root 3 minus 1. Too many negatives. So now I can rationalize that. So that's root 3 plus 1 over 1 minus root 3 times 1 plus root 3 over 1 plus root 3. Now, root 3 plus 1 is the same as 1 plus root 3. So this is really just root 3 plus 1 squared over, this is a difference of 2 squares. So it's 1 squared minus root 3 squared on the denominator. So that is a squared is 3 plus 2 times that is 2 root 3 plus 1 over 1 minus 3, which is 4 plus 2 root 3 over negative 2. And now we divide each term by negative 2. You okay with that? You divide each term by negative 2. So that's negative 2 minus root 3. So now they're getting interesting. Now,